Hey everyone, and welcome to this explainer. If you're gearing up for your upcoming exams, you are exactly where you need to be. Today, we're tearing down a really fascinating past physics question. It tests a core concept that, honestly, you're almost guaranteed to see again. Huge shout out to QandAHelp.com for bringing us this material. They're an absolute lifesaver for WAEC, NECO, and JAMB prep. All right, let's just jump right into it and see what we can figure out. So here's the actual question, straight from the WASSCE Physics 2026 archives. It's question number 7. It reads, a weightlifter lifts a weight of 2,000 Newton. If he holds the weight above his head, what form of energy does the weight have? And our options are A, kinetic energy, B, elastic potential energy, C, electric potential energy, or D, gravitational potential energy. Now, before we just jump to conclusions, let's take a second to unpack exactly what's happening here. We need to focus closely on the action and the final position of that weight. You know, every physics question has these little clues hidden right in plain sight. We basically get to play detective for a minute. Let's break down the really vital ones. First up, lifts a weight. That tells us an object was actively raised up from a lower point. Second, we get a specific force value, 2,000 newtons. Third, and this is a massive clue, the phrase holds the weight. Think about it. That means the weight has completely stopped moving. It's stationary. And finally, above his head gives us a very specific location. It tells us, without a doubt, that the weight is up at a height above the ground. Now, it is absolutely crucial to separate the act of moving the weight from its final resting position. While the weightlifter is grunting and actively pushing that weight upward, yeah, there's definitely motion involved. But listen to the phrasing. The question specifically asks about the energy when he, quote, holds the weight above his head, right at that exact second. Is it moving? Nope. Is it at a height? Yes, it is. And that distinction is literally everything. We're looking for an energy of position here, not an energy of motion.
Well, that whole energy of position idea points us directly to gravitational potential energy. By definition, this is the energy an object stores simply because it's been raised above the ground. It has the potential to do work just because gravity is sitting there ready to pull it back down. The formula for this is GPE equals weight multiplied by height, or, as you probably usually see it, mass times gravity times height, mgh. Now, you might have noticed we have a weight of 2,000 newtons from our clues. But wait, there's no height given. Don't panic. Actually, scratch that. Don't even worry about it. The examiners aren't trying to trick you into some weird math problem with missing numbers. There is zero calculation needed here. We're purely being tested on identifying the form of energy. Let's put this into perspective. Think about your heavy, giant physics textbook. If you just leave it resting on the floor, it has a really low gravitational potential energy relative to that floor. I mean, it can't fall any further, right? But pick that exact same book up and pop it onto a high shelf. Bam! It now possesses way greater gravitational potential energy. It's stored energy. If that shelf magically disappeared, gravity would immediately yank the book down. Our weightlifter holding those 2,000 newtons up above his head, that is exactly like the book sitting on the high shelf.
Okay, let's be super thorough and systematically eliminate the wrong options. Step 1, option A, kinetic energy. Well, kinetic energy is the energy of motion. But remember our detective work? The weight is held. It's totally stationary, so A is out. Step 2, option B, elastic potential energy. This kind of energy is stored when you stretch or compress something, like a rubber band or a spring. Our weight is made of solid plates. It's definitely not being stretched or squished, so B is out. Step 3, option C, electric potential energy. That deals with separated electric charges hanging out in an electric field. We're talking weightlifting here. No batteries, no voltages, no charges mentioned at all. So option C, crossed out too.
So, by process of elimination, we're left with only one logical choice. The correct answer is firmly option D, gravitational potential energy. The weight possesses all this energy purely because of its raised, stationary position fighting against Earth's gravitational field. You know, to make things a whole lot easier for your future exams, we can actually use a little shortcut. You can literally map specific keywords directly to their energy forms. If a scenario mentions a moving object, boom, that instantly links to kinetic energy. If you spot words like raised, height, or held above ground, that is your cue for gravitational potential energy. If the question says stretched or compressed, you're looking at elastic potential energy, and if it mentions separated electric charges, then you're dealing with electric potential energy. Taking a quick mental snapshot of these connections, that's going to save you so much time during the actual test. Let's just do a really quick recap to lock this in. Why does option D make perfect sense? Well, first, the word held tells us the weight is stationary, which completely throws kinetic energy right out the window. Second, the phrase above his head proves the weight is raised above the ground. Therefore, its energy is entirely due to its position in a gravitational field. This exact logic, that's exactly what you should follow whenever you face a question like this.
All right, let's put that keyword recognition to the test with a rapid-fire scenario. Say a student places a heavy school bag on a high table. What form of energy does that bag possess simply because of its height? Think back to our keyword cheat sheet. What do the terms high table and height immediately point to?
If you guessed gravitational potential energy, hit the nail on the head. You got it. The bag is raised above the ground, so it's actively storing energy just because gravity is itching to pull it back down to the floor.
Okay, let's keep the momentum going. Think about this one. A football rolls across a field. What form of energy doesn't possess because it is moving? Now remember, don't even think about height here. Just focus entirely on the action being described.
The answer for sure is kinetic energy. The massive clue here is the active movement. The ball is rolling, it's in motion, and because of that, it possesses kinetic energy. It's literally the exact opposite of our stationary weightlifter.
Okay, one last quick scenario to round this out. A stretched catapult stores which form of energy? Focus closely on that keyword stretched. Where did we just see that? Yep, it is elastic potential energy. Whether you're stretching the rubber on a catapult or compressing a heavy metal spring, physically changing the shape of an elastic material stores up that elastic potential energy. Honestly, really grasping these different energy forms gives you a massive, massive advantage in physics. If you want to dive into more step-by-step breakdowns of past questions just like this one, definitely head over to QandAHelp.com. It's an incredible library for WASSCE, JAMB, and NECO prep. So I want to leave you with this. The next time you see an object just casually resting on a high shelf, or maybe a rubber band pulled tight, ask yourself, what kind of invisible energy is hiding right there in plain sight? Keep studying, stay super curious, and I will catch you in the next explainer.